which provide us various types of waveforms like sine wave, rectangular wave, square wave, sawtooth wave. So all these types of waveforms are provided by the signal generators. So signal generator, they are the instrument which are providing us the various different types of waveforms like the sine wave, triangular wave, pulse train, and an amplitude modulated waveform. So depending upon the type of waveform provided by the signal generator, they are of different types like function generator, sweep frequency generator, audio frequency generator, pulse generator. So depending upon the type of waveform, they are the different types of signal generators. Now what is the use of these signal generator? Because it is providing these various types of signals, so these signals are used for testing the various electronic circuits in the laboratories. So at low power, if you want to analyze or test the various electronic circuits, we can use the signal generators. Now, what are the requirements of the laboratory type signal generator? As we are having the different types of signal generator which are generating the different waveforms, so the requirements will be, but the requirements for these signal generator will be the same. So let's see that what are the requirements of a signal generator. When we are using the signal generator in the laboratories, so we require that the output frequency of the signal generator, it should be very stable, because we are using that output waveform for other circuits, for other electronic circuits. So if the output frequency is not stable, there will be fluctuations in the other circuits also, and measurements cannot be done correctly. So the output frequency of the signal generator, it should be very stable. Now, not only the output frequency but also the amplitude of the output signal of the signal generator, it should be controllable between the lower values and the larger values, so that whenever whatever amplitude we want, suppose we want that the output waveform, it should be of low amplitude, so that can be controlled. Also, if we want that a waveform of very large amplitude should be provided, so we can adjust the amplitude according to our requirements in the laboratories. Now the amplitude, it should be stable, the harmonic content should be as low as possible, and the output should be distortion free. There should be no distortion, no harmonics, and the amplitude also, it should be stable. Another requirement is that The signal generator, it should provide an output which is having very low spurious contents in it. Spurious means the disturbances like the noise, the jitter, the modulation effects, they should be less in the output. Then only that output will be effectively used for other measurements. Okay. So these are the requirements of a laboratory type signal generator, that the output of the signal generator, it should fall, be in these limits. Okay, like it should be a stable, amplitude should be controllable, amplitude should be stable, harmonics free, there will be no harmonics, distortion free, and also it contains less noise contents in it, it will be less affected due to the disturbances. Now let's come to the construction part of the signal generator, that what a signal generator basically consists of and what are the different techniques used in it for the generation of the different waveforms. Now, signal generators are the instruments which usually produce a fixed frequency sine wave whose output can be frequency or amplitude modulated by another signal. So, in signal generators, they usually produce a sine wave, a fixed frequency sine wave, and this output sine wave, it is either frequency modulated or amplitude modulated by some another signal. Now the frequency range over which this instrument work, it is about 0.001 hertz to 50 gigahertz. So such a wide frequency range this instrument can be used over, but the same frequency range cannot be used for a single instrument. Means a single signal generator, it may be using less frequency range, it is not using this complete frequency range, but the various types of signal generator, they cover the frequency range from 0.001 hertz to 50 gigahertz. Now as you have seen that here in signal generator, both the frequency modulation and amplitude modulation is being used. So how this frequency and amplitude modulation is achieved in the signal generator, let's see. The frequency modulation in the signal generators, it is achieved by varying the voltage across a variable capacitance diode in the tuning circuit of the oscillator. So we will be using an oscillator. In that oscillator, we are having a tuning circuit. So tuning circuit and we are having a variable capacitance diode in that oscillator. So if we are varying the voltage across that diode, that capacitance diode, frequency modulation can be achieved. Okay. Now this frequency modulation, it gives a output distortion in the waveform. Okay. Now as we have studied that the requirement of a signal generator is that its output should be distortion free. So to remove this distortion, we have to use some techniques. Okay. So this frequency modulation, it gives a system with a low output distortion. Okay, so this frequency modulation is going to produce the distortion in the output waveform. This distortion will be low when the modulation depths are below 1% of the carrier frequency, but greater than this 1% value, if the frequency modulation is used, then it is going to produce more distortion, more output distortion in the signal generator. Okay, so during this frequency modulation, we are going to use some manual and automatic techniques, so that the amplitude of the output, it should be constant, there should be no variation in the output, and also this distortion in the output should be low. Okay, so this was about the frequency modulation. Next is the amplitude modulation. Now for frequency modulation, what we were doing, we were varying the voltage across the variable capacitance diode. For amplitude modulation, we are varying the supply voltage to the oscillator. Now frequency modulation has also caused some problems in the output. It has distorted the output. Amplitude modulation is also affecting the output, and there is a range that for up to about 50% of value, this amplitude modulation can be done, because this amplitude modulation not only not only produce distortions in the output, but also it is going to give the phase modulation in the signal. Okay, okay, so in the signal generator, we are using the frequency modulation and the amplitude modulation. For frequency modulation, we are changing the voltage across a variable capacitance diode of the oscillator, and for amplitude modulation, we are varying the supply voltage to the oscillator. Now let's see the block diagram of the basic signal generator, where we are using these two techniques for the frequency and the amplitude modulation. So this is the block diagram of the signal generator, which is using the feedback method. Now here you can see that for the frequency modulation, we were using an oscillator, and we are varying the voltage across the capacitance diode, which is present in the tuning circuit of the oscillator. Now here we are having this oscillator, which are to which we are providing the input for the frequency modulation. If we want to provide the frequency modulation, we are going to vary the voltage across the diode. Now here we are having the input for the amplitude modulation. To the comparator also we are having one input which is from the detector. Okay, so here to the from the detector we are getting the output signal, and another input to the comparator is the input for the amplitude modulation. Now as we have studied that when we are doing the amplitude modulation, so this amplitude modulation also causes the phase modulation in the waveform due to the components which are present within the oscillator circuit. So to remove that output distortion due to this amplitude modulation and frequency modulation, we are using the feedback method in this signal generator. So due to this feedback, the output distortion will be reduced. What we are doing, this input from the amplitude modulation, it is provided to the comparator. We are detecting the output here. The output signal is given to the detector. Detector then provides the signal to the comparator. Now comparator compare it with the amplitude modulating input, and it is going to provide the feedback signal to this amplitude modulation circuit. Okay, so after amplification this signal is provided back, and the difference of this modulation signal from the output will be provided. So according to that, because here we are using the feedback of the output to be provided to the input, so that is why it is called the envelope feedback. Okay, so this technique which is used in the signal generator, it is called the envelope feedback. So in this envelope feedback, we are providing the feedback. We are using this feedback to remove the output distortion. How we are detecting the output, you can see in the block diagram that with the help of this detector we are detecting the output. After that we are comparing it with the amplitude modulation input. So after detecting, this is compared with the amplitude modulation input from here. After comparison the error signal will be generated, and that error signal is first amplified and fed back to the modulation circuit. So that will be provided as the modulating signal to the output. That will be the modulating signal. Again it is attenuated, amplified and provided at the output. So this technique is called the envelope feedback. Now in this envelope feedback, the block diagram, you can see that we are using here the attenuator and the output amplifier. So what this attenuator is doing, it is used to give the low level output signal, and amplifier is used to amplify if the signal is weak. Okay. Now there is another technique which is used in the signal generator, which is called the heterodyne frequency. Second principle is the heterodyne principle. Now this heterodyne principle is used to give a continuously variable wide variety of frequency range. If we want that our output is having a wide frequency range and also it is continuously variable, so we can use this heterodyne principle for the signal generation. Now, earlier we have studied that if the frequency range which is provided by the signal generator, it is from 0.001 Hertz to 50 gigahertz. Now, this complete frequency range, it is not provided by a single instrument. But if we want that this wide frequency range, it is provided by a single instrument, then we can use the Heterodyne principle. In this Heterodyne principle, we are not only getting a continuously variable wide frequency range, but also the signal quality is good. Okay. The stability of the frequency, it is very poor, because here we are finding the difference between the frequency which is f2 minus f1. Okay, so here if both these frequencies f1 and f2, they are nearly equal to each other, so if any variation is caused in any of these frequencies, then it is going to provide distortions in the output. Okay, so if for frequencies, because the output frequency, it is the difference between the f2 minus f1, so if these frequencies are very close to each other and if we are making any slight changes in any of these frequency, it is going to produce a considerable amount of. Okay, so let's see the block diagram for this heterodyne principle, that how we are generating the signal by getting the difference between the frequencies. So just like in the signal generator, the basic element is the oscillator, which is producing the frequency and the amplitude modulation. So here also we will be having two oscillators. So this oscillator 1 is providing the signal of frequency f1 and oscillator 2 is providing the signal at frequency f2. Now output of both these oscillator is given to the mixer and the filter. After that, we are having the signal f2 minus f1. Okay, because we are calculating the difference between the two frequencies. Again, the signal is given to the attenuator, and then we are getting the output. So this is a heterodyne oscillator where we are getting the output, which is the difference of the frequency between the input signals. Another technique which is used in the signal generator is the multiplier and the divider technique. Now, if we further want to extend the frequency range from a single instrument, we can use the multiplier and divider techniques. In these techniques, we are using a multiplier. We are using a in this multiplier generator, what we are doing, the output from a fixed frequency oscillator, we will be using an oscillator. So the output of that fixed frequency oscillator, it is fed through different multipliers. Okay. Okay, so in this multiplier generator we are using the tuned multipliers and the tuned filters. Okay, the we are having a fixed frequency oscillator, so output of that fixed frequency oscillator is given to the tuned multiplier. We are having different tuned multipliers in that, so at every stage the output of the tuned multiplier is given to the tuned filter, which is going to select the high frequency output. Now here also frequency modulation and amplitude modulation are to be achieved. So frequency modulation is applied to the master oscillator. Okay, so for frequency modulation, that will be applied to the master oscillator. Again we will be varying the voltage across that tuned capacitor, and for amplitude modulation we will be varying the supply voltage, the DC supply voltage, to the last multiplier stage. Okay, now let's see the block diagram for this multiplier and divider technique. So this is the block diagram which is using the multiplier and the divider technique. You can see here we are having a master oscillator, which is the fixed frequency oscillator, to which we are applying the input for the frequency modulation. After that, the output of this is given to the multiplier stages. The output of the multiplier is given to the tuned filter. After this tuned filter, the output of this tuned filter can be either taken as the final output, or it can be given to the next multiplier stage. Then again tuned filter, output of that tuned filter will be applied to the next multiplier stage, and then we are having the final output of our signal generator. Now to the last multiplier stage, we are providing the input for the amplitude modulation. So there can be various multiplier stages in it. Now there is one disadvantage of this multiplier generator, that it provides a large amount of spurious signals at the desired frequency. So you can see that in this multiplier and divider techniques, the output of this frequency master oscillator, it is divided by a series of electronic stages. Here we are having different stages, so these stages are multiplying also and dividing this output also. Now the output from these divider stages, it's a square wave. Okay, So here in this block diagram, we are having the output from the divider stages. It is a square wave, so that will be converted into the sine wave by providing some filtering techniques. So here the square waves are filtered. We have used the tuned filters here, so they are converting the square waves into the sine wave. Again, for frequency modulation, we are using the master oscillator, and for amplitude modulation, the voltage, the DC supply voltage to the last multiplier stage, that will be varied. So in this way, through the signal generator, we are getting the different waveforms which are in a specific frequency range. Now, the first method which we studied was the angular feedback. In that, from a single instrument, we are getting the frequency range which is less. Now, if we want that we want a wide frequency range from a single instrument, then we can use the Heterodyne principle also. But that Heterodyne principle, it introduces spurious signals in the output. Okay, so to remove that, we were using the multiplier and the divider techniques. So due to the divider techniques, the spurious signals are reduced in the output waveform. So they were used for the formation. These techniques are used in the signal generator for the generation of different waveforms. So in this video, we studied that what is a signal generator, what are the requirements of a signal generator which is used in the laboratories. Then we see the different techniques which are used in the signal generator, the angular feedback, the Heterodyne principle, and the multiplier and the divider techniques. So I hope that this topic is now clear to you. Thank you.